Right, today I'm making a video on this question here, and it's to do with completing the square, and it's completing the square where b in the quadratic equation, here we have it here, is a negative number. So when b is a negative number, it does make it a little bit harder. If it was plus 6x, then you could start to do it, produce this geometric proof down here, whereas the red square that's behind all these shapes would be x plus 3 all squared, and this red square you can see is made up of x squared plus 3x, which produces 9x, and then it's also plus 9. So it's a little bit easier to see it when b is a positive number. At this time, b is a negative number. So I'm going to do it in a slightly different way. What I'm going to do first of all is I'm going to see what happens when I have x minus 3 all squared. Because we know when we we're looking for two numbers that would, if we want to factorize this, we could be looking just this bit here. We would be looking for two numbers that that add to give -6, and if we want those two numbers to be the same, then it'd be -3 and -3. So if we just concentrate on that bit to have a little play, and we can see what would happen, and we'd get x squared minus 6x, which is great, but then we'd have plus 9. Okay, so you can see how it's a little bit different to what I get over here, where I factorize x plus 3 instead of the plus 9, but I have plus 6x. So that's the first bit then. Now that means that x squared minus 6x plus 1 is going to be equal to, well, it's equal to x minus 3 all squared. And what I've done is I would have taken away 8 in order to get that. So it looks at the moment as if a is 3 and b is 8. So this can be tested by putting the equation into a graph. We can test it a number of ways. We could factorize that back out and we'd see that that's the correct one. We could also put this into a graph using Desmos, which is a very good website for graphing functions. And if you put y is equal to x squared minus 6x plus 1, and it'll plot a graph. And then if you do y is equal to this equation, you'll see that the graphs are identical. They overlap from one on top of one another. So we have correctly completed that. Now that means that a is therefore equal to not -3 but 3, and that b is equal to 8. So the whole point of completing the square, really, or the main point of completing the square, is that it helps you to find the turning points. Turning points really means in this case it would be the minimum value for y. So you'll get all quadratic equations all quadratic graphs will produce a curve either like this or upside down. Depending on whether or not a, then the multiple of x's is positive or negative. If it's a positive value, then it's going to look like this. If it's negative, it will look like that. So the value that we're finding out, the coordinates that we're finding out, is this point down here. That's the minimum value, or the point. The reason why it's called turning point as opposed to minimum value is because it could be a maximum value, like that. And so we call this the turning point, and that's what we're also being asked to find out in here. Now, we've been quite sneaky because what we've done is they've made both these negative values. Actually, this is often the way it is defined, to be fair, in the oh no, well, okay. So all right, so basically they've made both these negatives. Now this is a little bit confusing because if you were to plot this, you'll notice that the y value is -8 for the turning point. So this, where we, so let's go x minus a all squared minus b. Well, the 8 was, well, this is -8. So in other words, if we had a plus sign there, then we would be able to say that b is equal to the y value. Well, because we don't have a plus sign, then basically we'd have to say that b is equal to the negative y value for the turning point. So, and then you can see here that the you can't see, but if you plotted it on your graph, you'll notice that that's 3, and so that's the so that a is the x value for the turning point, but this is the positive x value. So because they've done take away 3, so the turning point, the coordinates, is going to be 3, -8. Okay, so that's completing the square using when b is a negative number. It's a little bit more tricky than when it's a positive number, because when it's a positive number you can use this sort of geometric proof, but once b is a negative number, then the geometric proof, you could probably still do it with this geometric proof, but it's a bit difficult because if I made the diameter of this -3, then I guess you have to say it was down here, and then if you move, and this would have to move back there, and then as you can see they overlap, and so something would have to be done to apply the same geometric proof. It won't really work. In any case, that's the answer to that question. A is 3, B is 8, and the coordinates for the turning point is 3, -8.